Hi everyone, and welcome back to my YouTube channel. For those of you that don't know, I'm Andrew Hoffman, a security architect and technical author based out of the Pacific Northwest. I wanted to do a fun video today, so I'm jumping back to the JavaScript programming language. In this video, I'm going to show you 5 features of the JavaScript programming language that you probably aren't aware of, and it's unlikely, I think, that you've ever used them before. Now, what I want you to do throughout this video is, if I'm wrong, and if you are aware of one of these features, or you have used them before, I want you to post in the comments below the video where you learned about this feature and how you used it. Now, the features I'm going to show you, we're going to start in order of most likely that you've used them before or are aware of them. And towards the end, once we get to features number 3, 4, 5, I think it's going to be less likely that you're aware of these and much less likely towards the end that you've made use of them. So let's jump into it. So right off the bat, we're going to talk about something a little bit simple, but it's nuanced within this particular language. We're going to talk about how variables are scoped within JavaScript. So you see I have a couple of functions here: var test, let test, const test, and global test. Now at the top, if we look at var test, first we declare var a equals 1, that's a new variable declaration. Then we say if true, so this is a new block, var b equals 2. Then we say console.log ab. Well, in most programming languages, variables are block scoped by default. So what that means is var a would be exposed to console.log, but var b, because it's in an inner block, would not be exposed to console.log. Okay, well, what do you think is going to happen since this is JavaScript? We're going to run this and we're going to find that both of these are actually exposed to console.log. The reason why is because in JavaScript, var defines a function scoped variable. That means regardless of where you declare the variable within a function, it is accessible at the top level function, so it is function scoped. You can see we have 1 and 2 visible from the console.log right here on the right hand side of the screen. So moving on to number 2, let test. We have let a equals 1, and then we have another inner block that says if true, let b equals 2. So what's going to happen different here now that we have let instead of var? Well, in order to accommodate for the features that other programming languages had that JavaScript did not have in the beginning, rather than taking var and making it block scoped, which would break a lot of existing code, they introduced a new keyword, let. So if we do let test, what I can tell you is going to happen is this let is going to be block scoped. That means the console.log will have access to the variable a, but not to the variable b. So as you can see here, b is not defined. So the console.log was not able to get access in the scope chain to b because b was in an inner block. Okay, so that makes sense. So what is const? So we look over here at const test, and just like many other languages, this is not something nuanced that I expect that you would not be familiar with. Const is a block scoped version of let that cannot be reassigned. So if we try to reassign it right here, we'll see that we take let a equals 1, we reassign it to 2. Probably won't get an error. It wouldn't make any sense because that's not how it is defined in the spec. But then we have a try catch block and we try to reassign b to 2. Now b is a const. So let's just do this right now. We go const test. We run it. Cannot reassign const. Okay, so const is similar to other keywords like final in other languages. Everywhere from var test to const test, I assume most of you are familiar with. Now where it gets a little bit weird and where I think a lot of people aren't familiar is what happens down here, the function global test. We say a equals 1. What happens when you define a variable in JavaScript without using a keyword like let, const, or var before it? Well, let's just try it. So we run the function global test, and it turns out that a is defined. Okay, interesting. And then window.a is also defined. So this is a weird quirk of the JavaScript programming language, a feature you could say, or perhaps a bug, some element of the legacy spec. What happens when you do not use let, var, or const when you're defining a variable is the variable will get defined as a var, but in addition to that, a pointer to it will be put on the window object, top level window object, if you're doing it inside of the browser. Now this is really quirky. Why would you want to have a variable that is defined and accessible globally on top of this window object, which is a core part of the browser DOM? Well, it turns out in the past there were a lot of libraries that made use of this, circa 10-15 years ago perhaps, and they made use of this when they needed to store something globally so it could be accessed by other libraries, often state information. Now the reason that this is an anti-pattern now is because it turns out when you start using window.x and you start putting a whole bunch of data on window, you run into what's called scope pollution. So you start polluting the global window. And then what happens if you define a variable A, your library A, and library B also defines a variable A? Well, now you're actually both competing for the same namespacing. So this is considered an anti-pattern, but for legacy reasons, this is still something you can do in the JavaScript programming language in all major browsers. So that's some of the funky features around scope and defining of variables in the JavaScript programming language. Let's move on to the second set of weird and quirky features that I wanted to demonstrate in this video. So we move on to the second one. We're going to do a little bit of destructuring. Now this is a cool, quirky feature that JavaScript supports, and it gives you a lot of power that you really wouldn't expect. So I'll copy this block right here. Let's just look at the top. Let's do some basic destructuring. So let's say we define three variables, A, B, and rest. So in the JavaScript programming language, we can create this array right here with A and B in it, and we can set them both equal to 10 and 20 at the same time. So then we're doing two assignments at once within one line. We can just run this real quick, see what we get. So we would expect A to be 10 and B to be 20. Well, what does this destructuring operator right here do? Well, destructuring will refer to the rest of the elements in the array. So when A is assigned to 10, B is assigned to 20, then the rest will be everything beyond 10 and 20. The index is 30, 40, and 50. So if we console.log rest, we get, of course, 30, 40, and 50. So that's kind of cool. Now let's look at some more advanced destructuring that we can do here. So next we have variable swapping. So we define variables A and B equal to 1 and 3. Well, right here we can use a similar operation to actually swap the contents of those variables in just one line. So again, you can see A is going to be equal to B and B is going to be equal to A. So we would assume if we log A, we'll get the value of B, and if we log B, we get the value of A. Here we go. So A now has the value that was previously assigned to B, B has the value that was previously assigned to A, and we did this all in just one line. So that's a cool feature of destructuring in JavaScript. So let's go a little bit further. Let's see down here, let's see we have an array with 1, 2, and 3. And then within here we have an array position 2, array position 1, and we have array position 1, array position 2. So this is a deep reassignment that's occurring right here. And if we run it, 1, 3, and 2. So what's happening is 1, 2, and 3 right here is going to be elements 0, 1, and 2. And we're saying array at position 2, which would be a 3, is now going to be equal to array at position 1, which would be a 2, if I am reading this correctly. Let me see if I did anything confusing. So we have 0, 1, and 2. And here we have array at position 2, which would be the 3, which is going to be set equal to array at position 1, which would be the 2. Okay, so 2 should be at the end. Yes, that is correct. And then right here, we have array at position 1, which since it's 0 index would be 0, 1. So the 2 is now going to be set equal to the value which was previously the 3. And so we'll see 1, 3, 2. So we swap the positions of the 2 and the 3 all in one line right here using destructuring operators. Okay, so let's paste more of this. Let's go and let's look at some function destructuring. So right here we define a function, it's just called f, and it has a value. It returns an array with two elements. Index 0 is 1, index 1 is 2. And on the next line, we're going to say A and B is going to be equal to the output of f. So what we're doing is we're actually taking the result of a function. Notice we're not referencing the function as an object. We're actually calling the function. The function is returning an array. And so what's going to happen, order of operations, first of all, the function call returns 1, 2. And just like the destructuring that we did prior, now it'll look something like this. It'll look like 1, 2 after the function call returns. And then A will become equal to 1, and then B will become equal to 2. So that's another cool way that you can use destructuring in JavaScript. Now we can also ignore certain variables when we're destructuring. And as you can see right here, we have a function f, it returns another array, so we're doing that function call again. But in this case, we have A and we have B, and then we just have an empty space, so comma, space, comma. And what this allows us to do is create an array but only with the elements that we want. So we're selectively ignoring element index 1, which is equal to 2, which, as you can see, should give us the values 1 and 3. We get the values 1 and 3. And then here we say const c is going to be equal to f. And what do you imagine this will be equal to? Well, if we call c on f, we're actually just going to get the first value, index 0 of f, which will give us a 1, as you can see on the console output. So that's destructuring in JavaScript, a powerful set of features that allow you to manipulate objects and manipulate arrays and do things like swapping the values of two variables all within one line. So leave a comment below if you are familiar with that and where you've used it before. In addition to the prior one, if you're familiar with, especially down here, the global instantiation of a variable and its quirky context. Leave comments below on where you've used those and where you learned those. Let's move on to something a little bit more tricky that a lot of advanced JavaScript programmers and intermediate JavaScript programmers have probably used, but it's a little bit quirky. This is called the IIFE, immediately invoked function expression, and it's one of my favorite odd features of the JavaScript programming language. You can think of it as a function that automatically loads and can be easily namespaced. So let's start with a basic IIFE. So this is a function, as you can see right here, that is being called immediately, and it's also being wrapped in its own parentheses, which is important later on when we start using it to build namespaces. Now, right here, all we do is console.log test1. Now, when we run the application, this is going to run. So that's one of the cool things about IIFE is it's a function that is immediately invoked. IIFE, immediately invoked function expression. Okay, so that's a simple IIFE. Now, let's go down a little bit further and let's say, what if we want to avoid global namespace pollution? Now we're talking in example number 1, how we can pollute the window by adding too many attributes to it. And we can pollute global if we're putting too much data in global. So one way to do that is to create new namespaces. So here we have an immediately invoked function expression. Let me copy and remove this and copy and remove the prior example. So we have this IIFE right here, as you can see. And within this IIFE, we say let a equal 0, and then a is equal to, well, whatever a is. Now, down here, we're going to say try console.log a. So we're going to see if we have access to a. And if we can't find a, then what's going to happen, we're just going to console.log an error. Well, we're going to console.log that error. So what this means is we defined a, and it was invoked at runtime. So right when the script runs, it was invoked. And so the variable let a was defined in memory, but in the global namespace, we don't actually have to worry about pollution. In other words, we don't have to worry about how many names A, B, C, D we put inside this global namespace. And if we're redefining them later on, because it is being scoped specifically to this function expression. So that is a cool way of allowing you to use a number of different names within code that is invoked immediately upon loading your page, but not having to worry about namespacing conflicts. So what's next? Let's work with some top-level async. So a lot of browsers don't support async at the top level. This means if you want to use an async function, what you have to do is you have to build another function, and within these sub-functions, you can start using async await functionality. This is a way of handling asynchronous programming that does not involve promises or callbacks. So in these browsers that don't support top-level async, you can use an IIFE to implement top-level async. So an example of that is, as you can see right here, we have a function, timeout, it takes a milliseconds and returns a promise that automatically resolves at some time. So this is just an example of like a helper function for testing async functionality. And then down below we have this IIFE. And within this IIFE, we have an async function that it's wrapping. It's an async function that uses the shorthand function definition, so it just absorbs whatever the context right by it is. This is in comparison to using the function keyword. And right below this, we're doing a console log waiting for timeout, so we know that the timer is starting. And then we're using the await command that typically cannot be used at the top level of a page in browsers that do not support it. And this should wait exactly 1 second before console.logging timeout finished. And of course, waiting for timeout, you see a wait and then timeout finished. So using this type of IIFE, you can actually start using top-level async in the index.js of your code in browsers that do not support top-level async. So that's a cool quirk of IIFEs that you can make use of. And finally, let's talk about namespacing. I think this is one of the most valuable ways that you can use an IIFE because it allows you, and this has been used in the past, to define a single top level namespace. And within that namespace, you can have sub namespaces for any type of function or data or state that you imagine. And this is, you can think of it akin to jQuery. So in jQuery, you might call $, and then after that, you can call a function. Well, how could you define a namespace like that? You could use an IIFE. That's one method of accomplishing this. So as you can see here, we have const lib. And right now, we're actually setting this equal to an IIFE, but it's an IIFE using an anonymous function call. So if we call lib.dostuff, you'll notice that with an anonymous function call, we're not able to actually establish the top level namespace. What we have to do is first we have to create a function like this, and then we're gonna have to use the new keyword to instantiate a new copy of this function. And let's run this and we get stuff done. Well, how does this work? So starting in line number 1, we create this top level lib, which is just some data in the global quote unquote namespace. And then inside of here, we invoke this expression, this IIFE. And within the invoked IIFE, we have the this keyword followed by do stuff. So we're establishing in the context chain that the keyword do stuff is going to point to a function. The function is stuff done. And then when we say new, we just create an instance of this and we assign it to lib. So when we refer to lib, we're going to now be referring to this whole namespace that includes context, which includes function pointers. So here we say this.dostuff. Of course, we get this function. So when we say lib.dostuff, it says look at lib, then look at what's on lib, and then if dostuff exists, execute that function call. Now, interestingly enough, one of the best and most valuable reasons to use this is because you could put dostuff at the top level, but then it could be overwritten by another library, another programmer, another framework. But in the context of jQuery, everyone knows $ followed by a function call. As long as the $ is never overwritten, then you're never going to have any conflicts, and all of the function calls under that namespace are protected and available at any time throughout the DOM lifecycle. So now we're going to talk about a very unusual, deprecated in some browsers, feature of the JavaScript programming language, which is actually extremely powerful and is still in use today in all major browsers, even though the consensus is it's complicated and it'd be good to get away from it. And this is the with statement. You'll see we get a warning here in JSBen. It says don't use with. It overcomplicates your code, but it is very powerful. So let's imagine right here we have this function const no math equals function. And right here we try to use pi times 2. But pi is a variable underneath the math namespace. So if we call no math, what we should get is an error because it cannot reference pi. Reference error. Pi is not defined. Okay, interesting. So if we call math down here, you'll actually see we reference pi correctly, math.pi. So let's just call math. And this should calculate correctly. We get 2.2831, etc. So what if we had some block of code and we wanted to routinely reference a variable, let's say this state information pi, which is 3.14xxx, but we didn't want to have to call math before it every time? Well, what we could use is this function with, and what this will do is it will actually hoist math to the top level of the scope chain of the with math function. So if we go here and we go with math and we run it, you'll see we get the same output as we did from calling the math function. Now the math function called math.pi, but inside the with math function we only called pi. And that's because now when we reference pi, what's going to happen is the interpreter is actually going to look for pi in the scope chain, and the scope chain is going to have math very early on in the scope chain, and it will see all of the variables that were underneath math. So all of the attributes of math will be accessible within the with math scope chain. And as you can imagine, that can make the programming model very complicated and very hard to debug, but at the same time, it's pretty powerful. And I imagine there's a number of very useful things you could do with this if you're trying to write some very complex JavaScript code, maybe some code where you manipulated the namespaces and provided some process isolation to your users, etc. So that's the with statement. Finally, let's move on over here. Proxies and reflect. Okay, this is the final and maybe one of the quirkiest JavaScript features. Now, one of the reasons why I anticipate most JavaScript developers have not used these features is because proxy and reflect are generally only needed if you're building quote-unquote low-level JavaScript. If you're building frameworks, libraries, if you're building something along the lines of React or Vue. If you're just building web application code, it's unlikely you'll ever find or regularly, routinely find needs for either proxy or reflect. So let's talk a little bit about what proxy or reflect are. So here we have this variable called car, it's a const, and it has some data, so it's an object, it's like a JSON. It has a key and a value, model is the key, and Honda Civic is the value. And below it we have p equals new proxy car, and then right here, what do we have? We just have an empty object. Okay, interesting. So below the proxy, we refer to the proxy by p, and we add this data to it called year, and we set year equal to 2020. Okay, so car has a model, but car does not have a year. But now we're saying that p is a proxy for car pointing to this empty object. So when we say p.year, we're actually applying this data to the empty object here. So the empty object is going to have one attribute, it's going to be year, and it's going to be equal to 2020. So the way a proxy object works in JavaScript, it has a handler and a target. So we take this car, and this is the data that we want to intercept. It's the data right here. And then we apply another object, which could also be a function, and that's what we want to apply to the data that we're intercepting. So after we define this proxy, what's going to happen is if somebody calls car and they call car.year, well, the first thing that's going to be looked at is not car, but it's going to be the proxy that intercepts car. So we're going to see car.year, and that's going to refer first to p, and p has a year of 2020. And now we're going to say car.model, and p does not have a model, so then we will go through in our lookup to car, and we will return the model attached to car. Okay, so here we have 2020 and Honda Civic, just like that. And just to further make this point, that the proxy intercepts calls to the car, or calls to any object, if we put a year on top of car right here, and we say 1999, you would expect that the first thing would happen would, if car was being referenced initially, and so the lookup chain hit car before it hit p, because right when the lookup chain finds the attribute it's looking for, it's going to return. So if car was referenced first, we should get 1999. But in case of reality, if we run it, we still get 2020. And that's because proxies get put in front of objects. So a proxy lets you intercept data and function calls, and then manipulate what's going on prior to passing those to the original object or to the original function. And this can actually be really useful. You could imagine a library where you have some type of sanitization occurring. So you want input sanitization. There's a wide number of text fields of various types. Well, you could just intercept all those calls and run your sanitizer, and then pass the data through or modify the data to be less malicious using a proxy object. Okay, so we've gone through the basic case. Now let's talk about intercepting using reflect. So here we have const target, and this has two messages, 1 and 2, hello and everyone. But we want to say hello world. So in this case, our target right here, we're going to be intercepting for this object, the one that says hello everyone. And the handler for this proxy is going to be right here. The handler is an object that uses a reflect property, is what it's called, get. And what that's going to say is, if we're retrieving the data, then pass through these parameters to the function get. And this is a built-in functionality in JavaScript. It's part of the reflect API. And right here we say if prop is equal to message2, so prop is going to be the value, the name of the property on target, which is getting passed through if we reference target. But we only want to look at message2, which is supposed to be everyone. So we put this block here, and we're going to say if message2 is being requested, then return world. So this is going to return prior to returning everyone. Okay, so we're going to return world rather than message2, because the proxy will intercept and change the way that the target is accessed. Now what we're going to do is, if we don't actually have message2 being requested, we're going to use the reflect API to just return whatever they requested. So the reflect API is going to get the argument as long as it's not message2. There's only two properties right here in this object. So if it's message1, we return message1. If it's message2, we return everyone. Okay, so jumping down here, we can see we set up the proxy the same way as prior. And what you can see is probably going to happen is we're going to return hello because we jumped down here, we reflect it back, but then message 2 will get intercepted and we will return world instead. And as you can see on the right hand side, we have returned hello world, and we have intercepted and modified the way in which this target object would typically be interacted with by making use of both the proxy API and the reflect API. So these are the 5 quirky JavaScript features that I wanted to demonstrate today. Again, if you have used any of these features before, post a comment below on where and why you've used them, and also post a comment describing how you became aware of these features, since some of them are used less frequently than others.